This is Lesson 3, Activity 2, Transformation Information. And there are 8 figures in this activity, and I've done one of them as a separate video, the figure on rotation of a triangle with the center of rotation outside the triangle, so a point other than on the triangle. So there's a separate video for that. This is the other 7 figures. Now, this figure is a figure of a reflection, and so this pink shape here, this pink quadrilateral, is a reflection of this blue quadrilateral, and the line of reflection is right there through the center. And I, just by shading a little bit differently, I came up with this shape that has this really weird optical illusion. So if you stare at it long enough, it flips back and forth, and it will make you dizzy. We will come back to that in a little while. All right, so this is figure 1. And figure 1 is the translation. So they want you to move that triangle ABC from A to A prime. And again, the A prime, the prime just means it's the corresponding point labeled the same A, but they just want you to know that it's the corresponding point to this triangle. So you're going to move this A to this A prime. And there are lots of ways to do it, but one way is to think of moving it up 2 spaces or 2 units, rather think of them as units, and over to the right 6 units, 1, 2, 3, 4, 5, 6. Well, if you make that move, then the point about a translation is every other point on that triangle has to make that same move. So you move up 2 units and to the right 2 units. So up 2 units, to the right 2 units to get to B prime, up 2 units and to the right 2 units to get to C prime. Then connect the points. And actually, if you connect each corresponding point, so we're going to continue to get used to that word corresponding. It means A to A prime, B to B prime. It's the point that corresponds to the original point. So if you connect the corresponding points, and if you, first of all, they all will be parallel to each other because these points have to move the same distance, the same exact distance, and the same directions. They're all going to be at the same angle from the original image. And if you color in the image, the figure, you get a prism. So a prism is when 2 bases, there's one base, and the second base is a translation of the first base. So you're moving this base and translating it, moving it from one spot, the original spot, to another spot. And these bases are connected. Each corresponding point is connected, or each corresponding side, I should say, is connected by a parallelogram in this case. So the orange one, and on the other side, you just barely see it, but the black one on the other side. So this is not in the curriculum, but I always, when I look at these translations, I continue to see prisms, and prisms we studied in 7th grade. All right, figure 2 is another translation, but now you're going to translate this triangle from C to C prime. So you're going to go up 1 unit and to the right 2 units. So every other point is going to go through that same move, that same transformation. So you're going to translate ABC to A prime, B prime, and C prime by moving them up 1 point and to the right 2 points. If you connect the points on the translated triangle and then connect the corresponding points, line segments, and color it in a little bit, you get another prism. So this is the base of the prism, and the original base, A, B, C, can't see, it's covered up, but it was translated to this second base, which is A prime, B prime, C prime. And each corresponding side, once again, is connected by a parallelogram. If they right prism, they're connected by rectangles. This is reflection. The way to think about a reflection is, so they give you the line of reflection. So reflect this figure, ABC, over this line of reflection. So you're going to draw perpendicular lines. That's another word we're going to continue to get used to. A perpendicular line is a line drawn at a right angle to this line, this pink line. So you're going to draw a perpendicular line from each point to its corresponding point, which is an equal distance, the same distance from the line of reflection. So this point C is going to go across perpendicular. It's going to go 1 unit to get to the pink line, so it's going to go 1 unit on the other side. 3 units to get to this pink line L, 3 units on the other side. So these lines are perpendicular. And finally, 1, 2, 3, 4, 5 units. 1, 2, 3, 4, 5 units. So place each of those points, and they would be, if I label them, they would be A prime, B prime, A prime, B prime, and C prime. All right, so figure 3 I already did. This is figure, figure 4 was what the translation that we just did. So these are figures 5, 6, 7, and 8. So 5 is a rotation of 60 degrees. We're going to do this in more detail in a moment. 6 is also a rotation, but different center of rotation of 60 degrees. So when you use isometric dot paper, you're usually looking at a 60-degree rotation. One time so far, I've seen where the authors ask you to look at a 90-degree rotation in isometric grid paper. Most of the time it's 60 degrees. This is a reflection. This is that figure right at the very beginning, and this is a translation. So let's look at these in a little bit more detail. So this is a rotation around point B. So point B is the center of rotation. And remember, these are all equilateral triangles. So this is a 60-degree rotation from this side here to this side here. So this is a 60-degree rotation. And you can check that this is the center of rotation by counting. So I'm going to count along from the center of rotation along the side of the equilateral triangles. So to get to A, it's 1, 2, 3. And then I'm going to rotate 60 degrees. I'm going to count from the center of rotation 1, 2, 3. And you get to the corresponding point. This should be labeled A prime. To get to B is the center of rotation. To get to C, I'm going to count along the side of the equilateral triangle and then in the direction of rotation. So this is 1 unit and then 1 unit in the direction of rotation. So then you rotate 60 degrees and you count 1 unit and 1 unit in the direction of rotation. So you get to C prime, should again be labeled C prime. And to get to D, it's the 1, 2, 3 units that we did to get to A, and then 1 unit in the direction of rotation to get to D. So 3 units out, 1 unit in the direction of rotation to get to D prime. So that is a 60-degree rotation. That's that counting strategy to be able to check to make sure that you rotated it correctly. This is another rotation of 60 degrees. This is a clockwise rotation. The last rotation was counterclockwise. Clockwise rotation around point C. So again, this is 60 degrees. It's going to go from this edge here. It's going to rotate up and land right here after the rotation. So I'm going to count along the sides of the triangle. And I'm going to check the location of D. I'm just going to count out 1, 2 units and count out along this. So I'm going to rotate 60 degrees and count along this side 1 unit, 2 units. You get to D prime. It should be D prime once again. To get to A, I'm going to count out 1 unit, and then in the direction of rotation, 1 unit. Get to A, rotate 60 degrees, count out 1 unit, 1, direction of rotation, 1 unit. So that gets me to A prime. And B is interesting in that you have to count in the opposite direction because it lands on the other side here. See, I just have to look. I'm going to count 1 unit up along this edge and then 3 units over in the direction of rotation. I could count this way, 1 unit and 1 unit I'm going to count this way. 1 unit up and 2 units in the direction of rotation. I'm going to rotate 60 degrees to here this time. I'm going to count out 1 unit and then 2 units, 1, 2 in the direction of rotation. So B is a little bit different in that I'm not counting along this edge to start with. So I have to look at where it is and adjust to that. But you can still use that counting strategy to check. All right, this is the reflection. So I'm going to reflect this image, this pink image, over this line of reflection like a mirror to the other side. So I'm going to draw lines that are perpendicular, form right angles. And so if I draw a line from A to the corresponding point, it's going to go 2 equilateral triangles through the middle of equilateral triangles, 1, 2. So that means I have to count 1, 2 on the other side. So that's A. This should be A prime. B, 1, 2, 1, 2. This would be B prime. C is 1 unit to get to the line of reflection, so it's 1 unit on the other side. So this would be C prime. And D prime, 1 unit to get to the line of reflection and 1 unit on the other side. So the corresponding points are an equal distance from the line of reflection along a line that's perpendicular. So what's perpendicular? It forms a right angle. Now with a little bit of creative shading, you get that weird optical illusion. So I shaded it in this case, and I didn't shade it in any kind of odd way. This side covers up a little bit of this. I think of this as a kind of a tent. You might be sitting here, and this is the tent that's above, kind of a shade region, something like that. These are the sides, and this is the back. And actually, it kind of, this one still has that optical illusion. This kind of flips in and out from the front to the back, but it's mostly, for me, it's mostly in the back. So go back just a little bit. I just shaded this in right here. This side covers up this blue region. Now, if I change it and I put this line on the back side behind this, actually it's a trapezoid, behind this trapezoid, and then shade it in, and I don't cover up this section, I just shade this right here, that's when I get the weird optical illusion. So I didn't extend the line in front, it's now behind, so I shaded this in, it covers up that line, and I didn't cover this part when I shaded. So now you just look at it, and you get this image that flips back and forth. Look at it long enough, it will make you dizzy. Is this in the back or is this in the front? Are these two, this blue top and this pink bottom, are they going into the page and going to meet at an angle in the front? Or are they coming out of the page and spreading farther and farther apart? And notice this blue section seems to be twisted. To me, it's twisted to the left compared to this pink section. It's just a weird optical illusion that comes out of this shading. And the last one is a translation. So you're going to translate. These should be labeled A prime, B prime, C prime, and D prime once again. And each point is going to move just 2 units to the right. And a unit we're going to call the middle of the equilateral triangle. So this is 1, 2. This is 1, 2. C is 1, 2, and D is 1, 2. If you connect each of those points and then shade them, so now I'm going to connect each of the corresponding points, D to D prime, C to C prime, B to B prime, and A to A prime, and then shade. This is going to be the base of the prism. And in the back, you're not going to be able to see it, but it's actually this is the translated base of the prism, and this is going to be the original base of the prism. They're going to be connected by these rectangles, which are called faces or sides. In this case, it's a right prism. These are right angles, so it's a right prism. So you shade it. These are the rectangles that connect the bases. This is the blue base that was the translation. And so that's it. You have 3 different transformations. The encompassing word is a transformation. The category is a transformation. And in that category, or within that group, is a translation, a rotation, and a reflection.